Right, we're studying IGCSE chemistry and we're starting extraction of metals 3. Recap. Yes, Lula, tell me, what did we do?
We did extraction of aluminium, and then we learned the ore in the process, which was called Halt Heralds. And then we learned what's electrolysis equations and why anodes are replaced, why is aluminium extraction expensive, use of aluminium, and etc. And we wrote for the next class, which is for today, we'll be having rust prevention.
Alhamdulillah, you're good students. Alhamdulillah. All right, good. Now, some students are not really like you, and most are better than you, but you're not bad students. Good. Agenda. Today's agenda was rust prevention. See, I like students who want to study. If you want to study, I'll help you. If you don't want to study, then I cannot help you, sadly. But you do, so let's continue. Agenda, which is rust prevention today. Now, what is rust prevention? What is this thing, right? Well, rust prevention is all about two things. Well, there are many things, obviously, but two main things are, first thing is called sacrificial protection. Okay, and the second thing is called galvanizing. And there's a lot of other stuff in between, let's say, etc. Now we have to look at methods. So these are methods or methods of rust prevention. So what do you have to write in your notebook? Well, don't write any of this. Let's continue in the next slide. Right here, let's write rust prevention. First, write the definition. Rust prevention is adding other metals to iron. Just a second, I'll give you the exact definition from the book. Now, do you have your book open? Open the book, go to chapter number 16. Don't write the thing on the book on the board right now. Open your book and go to page number 319. Done. Now, well, actually 317. Rust, corrosion of metals. Let's start reading from here. Now, we need to use the book as well sometimes because it's important. Start reading from here, Lula.
The problem of corrosion. When a metal is attacked by air, water, or other surrounding substances, it is said to corrode. Most metals corrode. They undergo a chemical reaction with oxygen and other gases in the air to form compounds that collect on the surface of the metal. Some very reactive metals, such as sodium and potassium, need to be stored under oil to keep them away from the air and water. Others, such as calcium, will slowly corrode away to powder over time.
Okay, so what are they saying? What they're saying is we have different kinds of metals. Now, I've already told you, Lula, do you remember that how iron, alkali metals, they react with oxygen and they have to be stored in oil. Do you remember?
Yes, I do.
Now, okay, so what happens is, all we do is, because sodium is reactive. So let's write over here. First, under rust prevention, don't write any of this. Just write rust prevention, and then below write alkali metals or reactive alkali metals. Like Na, and now I'm not going to write sodium because you know what Na means, and lithium, let's say potassium, and even lithium. Let's say lithium, sodium, potassium, all of these are stored under R, or let's say react with oxygen in air and corrode. Hence, they are stored under oil. That's one thing. Now, other less reactive metals also corrode. Less reactive metals corrode slower, but all metals, so all metals corrode. All metals corrode. Write this, tell me when you're done. Now, can you see this on the screen? This bottle,
Yes, sir.
I'll show you one more of it, perhaps this one. That's not clear, this is clear. Now, this right here is called sodium. And where is it stored? It's stored inside oil. This whole liquid, this liquid here is oil. Because they're so reactive, if you put it in out of the box and expose it to air, it's going to literally turn into, it's going to react with air. So we don't want it to react with air. So we store it in oil. Fine. That's how bad the problem of rust is. If you put it in air just for, let's say, 10 seconds, 10 seconds, it's going to rust. Sodium. But iron is not that fast, obviously. Iron is slower, it's less reactive. Since iron is less reactive than sodium, it does rust, but not that fast. But it does rust still. So let's see how we can prevent this rusting. First thing first, let's see what rusting means. Okay, I'll tell you what rusting means. Rusting is corrosion of iron and steel is called rusting. Rust is Fe, let's say iron 3 oxide, is red brown solid Write all of this, tell me when you're done. Any questions? Safa,
No, sir.
look, this is also sodium under oil.
Yes, sir.
Rest, good. Now this question is asked in, this question stored in oil is asked in alternative to practical, ATP. You can write this in your notebook, ATP, important. It's guaranteed to come. Now, next thing we have to continue from here is read from here. From here, rest is a red-brown powder. Safa, read.
Rust is a red-brown powder consisting mainly of hydrated iron 3 oxide,
Okay.
Fe2O3,
F03.
XH2O. Water and oxygen are essential for iron to rust.
So let's try to be here. Conditions for rusting is water or oxygen. Water and oxygen. Fine, you need both of these, water and oxygen. Write it. Now, next thing is Next thing is salts increase rusting. Done. Finish writing, and we look at the more important stuff in a second. And on the top, just remove rust prevention and write rusting as the title. So let's say if I have a beaker like this, okay, and I put some water in it, and I put some metal in it, let's say something which looks like this, a big chunk of metal, and it's going to rust. And after rust, you'll see some orange stuff on the surface like this. I've shown you what rust looks like. Now, what the thing is, if you add, let's say, some salts in the water, okay, the rusting process will increase and it will be faster. You'll have much more rust here. Fine. So if you put some salt in water, it will increase the rusting process. Now, next thing, finish writing? Yes, no.
Yes, yes.
Okay, first thing first about, so then all of this was rusting. What is rusting? By the way, this thing condition is asked in MCQ. Because I remember questions, right? I've given the past papers. I know what questions they'll ask you. So this comes in MCQ usually. Rusting. Rust prevention now. We know what rusting is, how it happens, fine. Rust prevention. First step is, let's read the book. All of that is done. Okay, before we start rust prevention, we look at one more thing. Okay, I want you to change the wording for this just a little bit. In rusting, you wrote corrosion of iron and steel is called rusting, right? Now, instead of writing, remove this part, is called rusting, and add to form, add to form there. Or in place of is called, write to form. To form rust, which is. Tell me if you have any questions or problems. Next thing is corrosion of aluminium. Aluminium also rusts, but it forms an oxide, an aluminium oxide layer, which protects it from uh, air. Finished? How much have you finished, Diana? Progress? Diana? Mics on, all of you. Quick. Safa, progress.
Same.
How much have you finished?
9.
Second last line.
Last 9.
All right. Lula, progress.
Done, sir.
Done. Diana, where is she?
I think the network is not working for her. She was complaining about it.
What is not working?
The network.
Network. Now, last thing, so finally, we just look at rust prevention. First things are called barrier methods. 1, painting. 2, oiling, or let's say grease. Well, have you ever put grease on something to prevent rusting?
Grease
oil
as in
in-
like oiling?
As in oiling of gates and stuff?
No, I haven't.
You haven't? Has your father? I'll show you. Safa, have you ever put some grease or oil in some machine to prevent it from rusting or allow it to move properly? Have you done that?
Not me, my mom.
If you mean by that,
Or
we use it at the doorknob when it doesn't work.
Exactly, that's what I'm saying. So why does it not work? Do you know?
Because it rusts.
It rusts. Yes. That's why. Now, greasing is basically oiling. Oiling. So, last thing is plastic coating. Now, write all of these: painting, greasing, and plastic coating. Just a second. Is there anything important here? No. Okay. Okay. In painting, write. Just a second. Repainting necessary. Greasing provides oil layer that prevents contact with air. Right? Like we were putting sodium in oil. Now we're just putting oil on stuff. Instead of putting things in oil, we're putting oil on stuff. The other way around. Now plastic coating is PVC is used to cover. This is the PVC. I think that's pretty basic. Now the next thing we're doing is called, this is something different. This is called sacrificial protection. First thing, let's try galvanizing. Galvanizing. Putting a layer of chromium or tin on iron and steel to prevent rusting due to formation of oxide layer. Now, just a second, before you write any of this, please add one more thing: corrosion of aluminium, right? Chromium and tin are similar to aluminium. So in the sense that, or let's say chromium act similar to aluminium, in the sense that they all form an oxide layer, which protects it from air and prevents further rusting. What does this mean? If I have a metal like this, okay, it will form a rust a little bit. Let's say a layer like this, a small layer, but then what happens is it stops. Then this layer does not come off, okay, and then all the other things inside it, the green stuff, will not rust further. But something else happens with iron. If you have something like this is iron, okay, But what happens is the rust will fall off. Rust starts falling off. Have you seen it? How rust, if you try to pick rust, it will fall off, or you can peel it off, right? But that does not happen for aluminium. Aluminium stays like this. But what happens is these small flakes form and they come off. Then rust forms completely inside everything, and the whole thing becomes rusted. Unlike aluminium, this is iron. Any questions?
No,
No,
sir.
I'll ask you a question then. Why does aluminium not rust?
Because aluminium have an oxide layer which protects it from air and prevents further rusting.
Fine. So it does rust. Okay. Aluminium rusts, but forms in right. Fine. Yeah, it forms an oxide layer which prevents further rusting. Now do just one thing. Add the word here. Aluminium rusts, but forms. This word. Add this word right here. And I think that's enough for this. Add aluminium rusts, but forms. Next thing is galvanizing. So, okay, if aluminium does not rust,
So
it forms an oxide layer.
aluminium
Yes,
does rust?
it does rust, but the rust which it forms, it does not come off, right? So then what happens is if more air wants to go in, like this, let's say, if I have more air going in, I'll tell you what happens in the beginning. This is aluminium, right? And I have air going inside it. Something like air is coming over here. Then what happens is rust will form on the surface. Fine? Rust is formed. But after that, the stuff inside will not rust because this is the oxide layer.
Okay, understood.
Now, but iron, something else happens. In iron, I have the exact same thing. Look, I have the exact same thing. This is iron and something like this, and this is the metal. But when I blow air on it, it does not form an oxide layer. It basically forms these small chunks of rust, like this, gaps in them. Then the air still goes inside from here, from here, from here. Air keeps going in. And then inside will also rust, like this. And then the whole thing rusts and everything breaks down. Is that clear? Do you see the difference?
Yes, I do.
Now, okay, Diana, can you tell me why does aluminium not rust? Diana, say something.
Yes, sir. What's the question?
The question is, why does aluminium not rust?
Because it has like a prevention from rust. Like it doesn't allow the oxygen.
Okay, but what is it called? What is that prevention called? What does it form? Does it form something? Now, I want you to read this part.
Oxide.
Diana, read it out loud. Read the whole thing out loud. Out loud.
Aluminium rust but forms an aluminium oxide layer which protects it from air and prevents further rusting.
Now, tell me, why does aluminium not rust?
Because it forms an aluminium oxide layer which protects it from air.
Perfect. Safa, can you tell me why does iron not iron rust? Why is it different from aluminium?
because there's like the air can pass the rusting, it breaks
Yeah,
down and the air can pass to it.
exactly. Rusting breaks down. Also, amazing. Good job. Alhamdulillah. Now, but aluminium, the rusting does not break. It forms like a solid layer. It's very solid. But in iron, the rust flakes fall off. And then more rust happens, and that rust will fall. Then more rust will come, then that will fall. Now, look. Now, what can I do? Look. Please read this part, Safa, out loud. Chromium and tin.
Chromium and tin act similar to aluminum.
Okay, so if I have chromium like this, chromium does the exact same thing. Cr, chromium, it does exactly the same thing. Okay, what the problem is, it's not a problem, it's a good feature. If I put some air on it like this, from all sides, it will form a layer and then it will not rust anymore because that solid layer will stay there. Unlike iron, which fall off. But okay, so what we do now is, can I do something quite intelligent? That is, can I put some aluminium on top of iron? Whoa, what? Okay, let's see. Can I put some aluminium on top of iron? Like this. Now what will happen? If I put some air on it from all these sides, then again a rusting layer will form a small layer, very tiny layer
The
will form.
oxide layer will protect it.
So an oxide layer forms, it will protect. Oxide layer protects iron. And what is this called? It is called galvanizing. This is called galvanizing. Is that clear?
Yes.
So what happens is, since aluminium forms an oxide layer, what we do is we put aluminium on iron and it does not rust. So that is how it works. So iron is inside it, but this is aluminium on top. Since aluminium cannot rust, iron will also not rust. But the thing is,
So,
aluminium is expensive. Yes, go on, tell me.
can I I want a full definition for galvanizing. Like, I want to write it
Oh,
along
yeah.
with the notes.
It's right here. Look, galvanizing. Later, don't
Okay.
write any of this. We're just understanding what's happening. Writing
Okay.
and memorizing is not more important than understanding. Okay. Now we have aluminium. But the issue is aluminium is expensive. It's very expensive actually. So you can't use it. So what I do is, instead of aluminium, I put chromium, which is cheaper. All right.
But
Make
does
sense?
chromium have the same, like, does it have
Yes.
similarities with aluminum?
Right. Chromium and tin act similar to aluminium. Right.
Okay.
So you can also put tin. Tin is also fine. And now if I put chromium, what is it called? What is this iron called if I put chromium on it? It's called stainless steel. Now, Lula, can you tell me what is the composition of stainless steel?
Compositions as in how?
What is inside stainless steel? Check. Safa, tell me what is the composition of stainless steel? Alloy.
It contains, like you said, chromium.
And
I think carbon.
not carbon, not at all. Look at the book here. Can you see, guys, can you see the book? Now, silence is the worst thing you can do in my classes. So what you have to do, if you don't understand, ask me. If you do understand that, then it's okay.
Does it have
Let's look at.
aluminum?
It does not have aluminium. No, try again. It's close. You're pretty close to it. What does it have? Tell me. I'll show it to you.
Iron.
Does
Does it
iron.
have
Yes, it has iron.
iron, chromium?
And
Does it have more?
yes. Now, Diana, read
Steel.
this part. What does stainless steel have?
Nickel. No,
Iron.
chromium, nickel,
And what are the percentages of iron? How much iron does it have?
74%,
How much chromium?
18%,
And nickel?
8%.
So iron, chromium, nickel. That's what stainless steel is. You need to memorize this. Now, since iron, chromium, and nickel are inside stainless steel, and I know that chromium has forms a protective oxidizing layer. That is why it's called stainless steel, because it does not rust. It does not stain. Now let's go back to the chapter. We'll look at the final things, which is called All right, guys, can you hear me?
Yes, sir.
I want to make a difference here. Instead of galvanizing, call this electroplating. We'll look at galvanizing in a second. This is called electroplating when you put one thing on top of another. Well, all we're doing is like aluminium, we're putting chromium on top of iron so it does not rust. Understand the definition of electroplating. Write this down. Safa, read it out loud.
Electroplating, putting a layer of chromium or tin on iron and steel to prevent rusting due to formation of oxide layer.
Perfect. Now, sacrificial protection and galvanizing, or let's say galvanizing and sacrificial protection. I'll give you the definition. Putting zinc on iron or and steel to prevent rusting by process or by sacrificial protection. That is the definition of galvanizing. Now, what is sacrificial protection? Attaching a more reactive Now, quickly tell me when you're done. You start doing past your question. The chapter is done. Lula, read this out loud. Galvanizing.
Galvanizing, putting zinc on iron and steel to prevent rusting by sacrificial protection.
Diana, read this out loud.
Which one does?
Sacrificial protection.
Sacrificial protection, attaching a more reactive metal to less reactive metal to prevent rusting. More reactive metals rust or oxidizes, lose electrons in place of less reactive metal.
So what happens is galvanizing uses sacrificial protection. And what is sacrificial protection? I'll tell you what it means. You must have seen, let's look at a ship. Now, look at this layer. I'll show you the diagram over here. Now, please look at this diagram over here. Safa, read this part. Figure 16.12.
Blocks of zinc or magnesium are used for the protection of the hulls of ships.
So what we do is, there's another way to prevent rusting. If let's say I have iron, okay? And if I have on top of it, I have, let's say, sodium. Which is more reactive, Lula? Sodium or iron? Or let's say, sorry, sodium or iron?
Which is more reactive
Safa?
between sodium and iron?
Yes,
Sodium?
sodium is more reactive. It's group 1. Iron is group 1 are the most reactive. And even
Yeah,
based on
okay,
the
sodium
reactivity series, you'll realize that sodium is up there. So we have this is sodium, potassium, sodium, calcium, magnesium, zinc, iron. And you'll realize the higher the thing is, the more reactive it is. The sodium is more reactive than iron. Can you tell me, Diana, can you name any other metal which is more reactive than iron?
Then iron.
Yes, more reactive than iron.
Um,
You have the list given here. The higher something is, the more reactive it is. This is called the reactivity series.
yeah. Potassium.
Potassium. Safa, can you name any metal which is more reactive than iron, other than sodium and potassium?
Can I say?
Magnesium.
No. Magnesium. Perfect. Okay. Now, Lula, give me one more. Instead of calcium, what else do I have? Rest other than these 4, which is more reactive than iron.
Other than the top 4,
Yes.
more reactive than iron?
Yes.
Can I say
Yes.
zinc?
Zinc, right? This one. So these 4 are there, but all of these are more reactive. So any of these 5. So the zinc is also there. So I can use sodium. I can also use zinc because zinc is more reactive than iron. Obviously, it's higher. The more high something is, the more reactive it is. Reactivity increases as you go up the reactivity series. So what I do is I'll put zinc and iron here. Now when I'm going to blow air on it and air, water, and everything, can you tell me which is going to rust first, zinc or iron?
Iron.
No, more reactive rusts first because it's more reactive, obviously. So more reactive rusts
Okay.
first. So if I put some zinc on top of iron like this, or like this ship, they literally put a big block of zinc here, zinc bar. Okay. Now, Safar, tell me what will rust first, more reactive or less reactive?
More reactive.
More reactive. So zinc is more reactive than iron, so it rusts first. That is why we just put a zinc bar on top of the iron ship here. This is called sacrificial protection. If you put, let's say, something more reactive on top of less reactive, then what happens is the more reactive rusts first in place of the less reactive one. If all of this is finished, let's say this will finish. So the whole thing goes away. Okay. And then iron will start rusting. Is that clear?
Yes, sir.
Fine. Now the chapter is done. Okay, yep. So the chapter is done. Now putting zinc on lead. Yep, that's fine. Let's do some questions. Now we'll talk about sacrificial protection first. Now get ready. It's like a quiz. The one who answers first gets more points. You can revise your notes if you want to. Now, another question from the booklet right here. Look, start reading. Safa, read the question.
Sir, I can't see it properly.
You can't see it properly. Just a second. That's the problem of taking question out. Just a second. Now you can't. You could see it now. Okay. Now can you read it?
Yes, sir.
Start.
Titanium is produced by the reduction of its alloy. This is heated with magnesium in an inert atmosphere of argon.
Okay.
So the
Now, yeah, go on.
okay.
After this, yeah.
IC4 plus 2
Don't read that. Not that. This part. Explain.
explain why it is necessary to use argon rather than air.
Okay. Now quickly tell me. Titanium is produced by reduction of its chloride, heated in inert atmosphere of argon. Why will you use argon instead of air? Why will you not put a metal in it?
I think we'll use argon because it is a noble gas. It's part of a noble gas because it's in group 8.
Yes. Yes. Good. So okay, but how does it relate with metal? Titanium metal. Why would you want to not put air to a metal? Diana.
Because, oh, okay.
Luna in the chat. Safa, why will I put an unreactive gas? Argon is unreactive. Why is it unreactive? Because all group 8 are unreactive. Group number 8. So, and it's yep, it's called a noble gas. Now, why will I put unreactive noble gas on a metal rather than air?
So that it won't prevent rusting. I don't know.
It will
Prevent rusting.
prevent rusting, right? So we just say because titanium will react with air. I need to write the whole thing, not just prevent rusting. React with air, right? So because titanium will rust or react, we can say rust. We can say react in with air. That's the answer. Any questions?
No,
Now
sir.
we don't like. That's it. Now next answer. Name another metal that would reduce titanium chloride to titanium. It's about redox reaction. And since if you have missed the class, please write over here as a rule in your notebook, right? Rule of redox. The rule is more reactive reduces less reactive. And redox, let's say reduction and oxidation. Quickly write this, tell me when you're done. Oxidation is gain of oxygen or loss of electron. Loss of oxygen or gain of electron. Rules of redox, CH15. Finished?
Done, sir.
Fine, okay. That's done. Now let's look over here. Name another metal that would reduce titanium chloride or titanium chloride to titanium. So can you tell me which metal will reduce titanium? Now put to this word at the end here as well. More reactive element reduces less reactive metal salt.
So does this mean that we have to use a metal that's more reactive than titanium?
Yes. So name any metal which you think is very reactive.
Zirconium?
Zirconium. Now zirconium. Which metal is that? Just a second. I don't think that's a metal. Is that?
Okay, no, it's not. It's not.
It is a metal. Oh, it is a metal, right? It's but we don't study that in our syllabus. It's called zirconium. So give me another metal from this reactivity series. Look, something which is reactive, anything which is more reactive than titanium.
Potassium.
Potassium, most reactive. You can say sodium. You can say, look, calcium, magnesium is more. Magnesium is reducing titanium here. When I react with
Francium.
magnesium, say that again.
Francium.
Francium, no, because it is not part of your syllabus and it's not in the reactivity series. Fine?
So it has to be part of the reactivity series.
Yes, because that is all
Okay.
in your syllabus. Otherwise, you'll say radon, you'll say americium, all of those are there, but that's not in your syllabus, right? There are total 204 elements, so you can't name every one of them. So we take, let's say potassium, okay, done. Or we can say anything other than magnesium. So we can say potassium, we can say sodium, fine. Now, suggest how you could separate metal titanium from soluble magnesium. Okay, forget that. That's not in your syllabus right now. Well, we haven't done that yet. But I want you to do the next question, which is this one. Quickly read the question. Diana, read the question.
Titanium is very resistant to corrosion. One of its uses is as an electrode in the cathodic protection of large steel structures from rusting. Define oxidation in terms of electron transfer. The steel oil rig is the cathode. Name the gas formed at this electrode.
Stop. Diana, answer the first question first. Answer the first question. What is oxidation in terms of electron transfer?
Oxidation is like the gain of oxygen.
And in terms of electron, not in terms of oxygen. E minus is electron, by the way. So in terms of E minus electron transfer, it is gain of, okay, oxidation is gain of oxygen. But in terms of electron, what is it, Diana? Lula and Safa answer in the chat. It is louder, confident.
It's the loss of
Yes.
oxygen.
No, not loss of oxygen. No.
Black.
No. Now read the rules of redox, which you just wrote in your notebook.
Wait, so in case of this increase of electrons, I didn't understand the question.
The question is, they're asking us, what is oxidation in terms of electron transfer? So what happens to electrons in oxidation? Or how can you define oxidation in terms of electrons? Safa, you gave the correct answer. But Safa, I need only one answer. You're giving me two definitions. So what is the correct one? Oxidation is gain of oxygen or loss of electrons. Reduction is loss of oxygen or gain of electrons. So what is the answer over here? How can I
Gain.
define oxidation? It is
Gain of oxygen of electron.
gain of
Gain of-
electron. No, that's wrong. Okay, I want one of you to read this. Diana, read rule number 2 and 3. Quick, out loud.
Oxidation, gain of oxygen or loss as or loss of electrons. Reduction, loss of oxygen or gain of electrons.
So what happens to electrons in oxidation, Diana?
They gain or lose electrons.
They don't gain or lose electrons. They lose electrons only. They gain oxygen. So there are two definitions. In terms of oxygen, okay, let's divide it like this over here. So oxidation is gain of oxygen or it is loss of electron. So we write it is loss of electron. Is that clear?
Yes.
Now, what
Yes.
is reduction in terms of electrons? What is reduction in terms of electrons?
Gain of electrons.
Gain of electrons. Safa, what is reduction in terms of oxygen?
Gain of electrons.
Yeah, but what is reduction in terms of oxygen?
Loss of elect.
Loss.
Yeah.
Loss of
Okay.
oxygen. Okay. One last question from Safa. Safa, what is oxidation in terms of electrons?
Loss of
Electrons. So you're
Okay.
saying all the correct answers. Very good. Perhaps very good. Good. I think that is all we have to do in this. We look at, let's say, one question on galvanizing, perhaps. Now we can only do so many questions in class. There's so many questions, but we can't finish all of them in class. Now, just last question is, try answering this question, by the way. This is in your notebook, in your screen. Now I'm giving you questions from all chapters, chapter 14, 15, 16. Answer in the chat. Or Diana, read the question first out loud.
Which row gives the correct use for the two metals from which brass is made? Metal 1.
Okay,
Used
stop.
for
What is brass made up of?
Copper and zinc.
Copper and zinc. Now again, zinc is more reactive than copper, so it does not allow copper to rust. Now we realize why we put zinc and why we put chromium, because they stop rusting. Now, can you tell me what is the use of copper and zinc? A, B, C, D. Safa, what is the use of copper? Safa,
Yes, sir.
what is the use of copper?
I say
Can I say?
I don't
In
know.
the chat, please. In the chat. Safa, no worries then. See, I have more respect for you if you say I don't know. So you can learn. The first step is learning is saying I don't know. Then second step is understanding the answer. So I've gotten the answer. Okay. Diana, try one more time. And Lula, give me the answer. Which option is it?
A.
Diana, you don't have to say it. And it's not, I don't think it's A, perhaps. Maybe it is, maybe it is not. Write it in the chat. Diana, you're very correct. You're half correct. Okay. So you're half correct. Now, Safa, copper is very good electrical conductor. What is copper, Safa?
Say very good.
Very good.
Electrical conductor.
Conductor. Now, okay. Which of these do you think is a use for electrical conductor? Electrical wiring, galvanizing, making aircraft, cooking pans. Where will it be helpful to, or this property will be helpful? In which of these options?
User
wire.
see
Safa, say it louder.
B. Use of
B,
galvanizing.
steel. But this is a good electrical conductor. So do you think anything relating to electrical is here?
Yeah.
Electrical wiring.
Electrical wiring. So electrical wiring is used for copper because it's a good electrical conductor. So we use it for wiring, electrical wiring. Done. Okay. Now can someone tell me what is the use of zinc? Safa, tell me zinc. And Diana, tell me zinc. Nula, I need the answer in the chat. Safa, why do we use zinc, or where do we use zinc?
For preventing corrosion.
Preventing corrosion. Okay. Now, what is this process called? Preventing corrosion. When you use
Galvanizing.
zinc, galvanizing. So, what do you think is the correct option?
A.
A. Correct option is A. Luna, what did you choose?
For zinc?
For which of these options correct?
No, I have already written my answer. It was A.
A. All right. Then Diana, you chose B. You understand why it is A?
Yeah.
Because zinc is not for aircraft. Aircraft is aluminium. Always. Only aluminium. But well, brass does not have aluminium. It only has copper and zinc. So let's take this as zinc and this as copper. It must be electrical wiring and galvanizing. Well, this does have galvanizing, but this is aircraft. That's wrong. This has aircraft, obviously wrong. Cutlery, no. Electrical wiring, that's correct, but not cooking pans, so that's wrong. So the only correct option is A. Any questions?
No, sir.
Now look at the
No,
last
sir.
question. Safa, read the question.
Describe one method of rust prevention and explain how it works.
Okay.
Method.
So I want the answer in the chat. Name one process first. Yeah, I gave you so many processes, 5, 6 processes. Right? Name one and tell me how it works. First, name one. Method of rust prevention. Okay, Safa, I got your answer. And Diana, I want the name, not the method, but the name of the method. Diana, try one more time. I think you gave the correct answer, but I need the name of the method. So the ones which are in 1, 2, 3, 4, choose any of them. Okay, I've gotten answer. Now, Safa, tell me, how does your method work? And Diana, your answer is also correct, but now tell me, how does it work? So everyone has gained one answer. Now I'm waiting for how it works.
Can I start?
Just a second. Just a second. I need answer from one more person. Either Safa or Diana. Now, Lula, you gave the answer already. I'm waiting for Diana and Safa. Who's going to say how their method works?
I wrote mine.
You wrote your name. You gave the name, but how does it work?
Can I say it?
Yes, say it.
By like providing oil layer.
And after that, oil layer. After that, which does what? Which? Oil layer. What does the oil layer do?
Oiling.
No, but okay, fine. We get the oil layer. How does that prevent rusting? Let's go to the answer right here. Safa, you're remaining. Tell me, how does the thing you have mentioned, galvanizing, how does it work? And now, rust prevention. Now, Diana, read this out loud. You must have written this in your notebook.
Yes. Greasing, oiling, provide oil layer that prevents contact with air.
So why did you not say this part?
I didn't write the prevents contact with air.
Write it. Because then this is 0 marks in the exam, then if you don't write the whole thing. Okay, Safa, correct answer, but आपने galvanizing क्यों छोड़ दिया? Why did you leave galvanizing? The definition of galvanizing is here. Safa, read it out loud.
Pouring zinc on iron and steel to prevent rusting by sacrificial production.
So we know this now. It's not a big deal. You have to read the answer. It's in your notebooks. Just check if you've written everything. I think that's all for now. Any questions? Lula,
No, sir.
do you think this chapter is difficult?
No.
All right. What about Diana?
No.
How difficult is this chapter? Not difficult. All right. No. Safa,
Yes, sir.
is it
Sir.
difficult?
No.
No. Okay. There's no problem in it being difficult because everything is supposed to be difficult. That's why they're testing all of this. They won't test easy stuff. Then what is the point of testing? So just practice past papers, do chapter-wise questions. One way to start is by solving past papers, right, on all of these chapters. So that's it. Someone recap. Lula, what did we study in this class?
Today we studied about rust prevention and the reactive alkali metals and what is rusting and conditions for rusting and corrosion of aluminium, rust prevention and barrier methods, and what is electroplating and galvanizing and sacrificial protection.
Perfect. All right. That's all for now then. That's it. Then take care. Goodbye. Good luck for your test. Keep practicing.
Thank you,
Okay,
sir.
thank you.
Allah Hafiz,
Bye.
Safa. Goodbye. Take care.